Alright, so in this video, we're going to talk about the concept of work. And the question is, what is work? Well, work is going to be defined as the ability, to move an object, a displacement, call that d, by providing a force parallel to the motion. Okay, so a couple key factors here as you read this definition. Number one, it says that the ability to move an object, displacement d. An object must move for work to have been done. You know, for example, if I were to push on a wall, I can push as hard as I want to on a wall, but if that wall does not move, no matter how much force I provide, no work is being done onto that wall. Secondly, even though it's moving, it does not have to be accelerating. As long as it's moving at a constant speed or accelerating, does not matter. Work will be done if an object is moving. Now the question is, who provides that force or that work? The work is always going to be done by a force that is parallel to the motion. If an object is moving and a force is acting on that object, but that force is not in the parallel direction of the motion, then that force is not responsible for any work. Okay, so a couple key factors. An object has to move a distance d, and it has to be done by a force that's parallel to that actual motion. Okay, let's look at three different situations here. Let's look at case number one. So, case number one. We have a flat surface with a box that sits on that surface. And an individual wants to move this object from here all the way to there. So that front edge is going to move a displacement d, and it's moving to the right-hand side, basically. Okay? And we're going to do so by providing a force. I'm going to provide a force like such. Okay? And therefore, I am providing that force to the right as well. Since this force is acting parallel to the actual motion, and the block does move from here to here, work is being done. And what happens is that therefore, work is done by F. Okay, so work is actually done by this force F. Okay, well, let's look at case number two now. Case number two, we're going to have the exact same object sitting on a table, and again, we want to move it such that the front edge moves a distance d. So same thing. And again, this object is moving to the right. But this time, we do so by providing a force at an angle. Call that angle theta. So think about like a wagon. You have a wagon, and you pull on it with a handle that's angled a little bit. The object does not necessarily move up. It still moves to the right. But the problem is that this force F, is not parallel to the motion. But the question is, are there components that are parallel? Okay, well, if you remember anything by components, this is going to have two components. We have the x component, which is parallel to the motion, because this blue is moving to the right. And we have another component, which is the y component, but the y component is perpendicular. So we have a perpendicular component, and we also have a parallel component. Remember that the work is always done by providing a force parallel to the motion. Well, of these two components, only this horizontal blue, which I called Fx parallel, is going to be parallel. So therefore, the work is done by Fx in this case. And we're going to cut off a little bit here. So the work is going to be done by only Fx in this situation. Let's look at a third case here. Let's look at case number 3. Well, case number 3, we have exactly this. We have a man or a person of some sort, and he holds up a block. And again, he wants to carry this block such that it moves a distance d. Okay? But as he's holding it, basically, he's providing an upward force F. It's kind of like, imagine like a waiter or some sort. They have their hand like this, they have the tray sitting on top of it, and they just like walk moving forward to the table. Well, because they're holding it like this, basically, they're providing a force that's going upwards. So here, the motion is moving to the right, like such, and the force is acting upwards, which those two, now this force and this motion, are now perpendicular. The problem is that this force has no component that is parallel to this. So therefore, F does no work on the object. Well, then how did the object move? The object moved from this location to this location. We'll talk about what that work, what force actually did that work shortly. But as you can see, the work is always going to be done. The work is always going to be done by providing a force parallel to the motion. Now, it's also dependent on the distance. You know, as long as you're moving that object, there's going to be work being done. Now, the question is, what if that force is not always the same? So this leads us to our important formula for work. Work is equal to the integral from a certain x position to another final x position called the x1 of a force as a function of x, but as long as that force is parallel to the motion, and we're going to integrate this with respect to x. Now, because we're in physics 1, there's not going to be any calculus involved, what happens is that a lot of times we're going to be dealing with that if the force is constant. Therefore, if the force as a function of x is just equal to a constant F. Therefore, that leads us to your formula for work, where work is going to be F parallel multiplied by the displacement. Okay? Now, a lot of the textbooks, a lot of sources out there actually use the formula W equals FD cosine theta. I'm not a huge fan of that formula just because of the fact that it requires you to know which theta to always utilize. I just think that, okay, no matter what situation you have, make sure that you draw a diagram, a free body diagram, illustrating all forces, and determine if there are any components that are parallel to the motion. Now, it doesn't have to be in the same direction. If it's going to the right, the force does not need to be going to the right. As long as it's going into the right or the left, it's still parallel, and then multiplying that by the displacement. So now this is going to conclude the first part of work. In the second video, what we're going to do is we're going to discuss a little bit about how this formula can be utilized in Physics 1, and then we'll be doing a lot of applications of this, and we'll also be getting further into what we call like network and how that is constructed as well. So please look forward to the next set of videos, and that will complete the topic of work. Thank you.